How you doing, guys? Welcome to another video. This is volume 3 where we start to talk about the pH scale. Grab your calculator for this one. Let's go. Alright, volume 3, what is the pH scale? We look at calculating pHs, we need to distinguish between acidic, neutral and alkaline, and we introduce the ionic product of water. We basically look at a couple of formulas, we discuss what a pH unit actually shows in terms of concentration, and then we introduce this ionic product of water, and we're basically looking at some problem solving in this episode. So the acidity of the solution is a measure of the concentration of the hydrogen ions present. That is, the H plus ions or H3O plus ions. If the concentration of H3O plus ions is greater than the concentration of OH minus ions, then we say that it's acidic. If it's the other way around, we would say that it's basic. So, in terms of mathematical expression, concentration of H3O plus greater than OH minus, that's an acidic solution. A neutral solution is where those two concentrations are equal, and that might be something like pure water, has the concentration of H3O plus and OH minus as the same. And a basic solution is where the concentration of OH minus would be greater than the concentration of H3O plus. And if you have a look at that diagram on the left-hand side of the page, it tries to explain that in a visual sense. So the pH scale measures the acidity of a solution, and we have a formula to determine the pH. The negative log to the base 10 of the hydronium ion concentration or the H plus ion concentration. Remember, those two things can be used interchangeably. Because the pH scale is logarithmic, an increase of H plus by a factor of 10 increases the pH by 1 pH unit. That is, 1 pH unit is a times 10 factor increase or decrease of H plus concentration, depending upon which way you go. If the pH is known, the hydrogen ion concentration can also be determined by using the inverse of the formula. So the concentration of H plus is equal to 10 to the minus pH. These two formulas you really just need to know and remember for the exam. So here's an example. Describe the difference in H plus concentration for the following pairs of solutions. Black coffee at a pH of 5 and vinegar with a pH of 3. So if we think of this in terms of the pHs, we can see that vinegar is more acidic than the coffee. So vinegar has a hydrogen ion concentration of 10 to the power of 2 because it's 2 pH units lower than the hydrogen ion concentration of the coffee. That is, it's 100 times more acidic than the coffee. 10 to the power of 2, or 10 times 10, is 100. Another way we can start to think of this is every time we move down a pH unit, we're increasing the acidity by a factor of 10. So if something drops from pH 5 to pH 4, that's a 10 times increase in the acidity, and then from 4 to 3, that's another 10 times increase in the acidity. So some example calculations. If the H plus of an acidic solution is 10 to the minus 8, determine the pH of the solution. Okay, very simple use of the formula. pH equals the negative log to the base 10 of H plus or H3O plus. So we just sub in our hydrogen ion concentration, which was 10 to the minus 8 molar, and that gives us a pH of 8. There are no units for pH. If we were asked to identify this solution, we will describe it as being alkaline. Another example where we have a small amount of mole of nitric acid and we've added that to water to produce a solution of 0.8 decimeters cubed. We need to calculate the concentration of H3O plus and the pH of the solution. The first thing we need to do is calculate the concentration of the HNO3. We've been given the number of moles, we've been given the volume, so let's use the concentration formula, mole over volume. It was in decimeters cubed, so we don't need to change that. So we can determine the concentration of the solution. Now comes the important part for when we have acids and bases. We need to write an equation to determine the H3O plus concentration. So HNO3 will react with water to form H3O plus and NO3 minus. That is, it will ionize. The HNO3 ionizes in water to form the hydronium ion. Now in this equation, the relationship between H3O plus and HNO3 is 1 to 1. So the concentration of H3O plus is the same as the concentration of the nitric acid. So now we can determine the pH by just subbing in the negative log of H3O plus, which in this case was 0.00275 molar, to determine the pH of the solution, which is 2.56. This time, this would be an acidic solution. It's lower than 7, so it's acidic. Now, experimental measurements have shown that all solutions contain some amount of the hydronium ion and some amount of the OH minus ion, and the product of their molar concentrations is always equal to 10 to the minus 14. This relationship is called the ionic product, and it comes about from the self-ionization of water. Water can self-ionize, where two water molecules will react. One will act as an acid, and one will act as a base to produce H3O plus and OH minus. So we have this formula, Kw, the ionic product of water, equals the concentration of H3O plus multiplied by the concentration of OH minus, and at 25 degrees, that's equal to 10 to the minus 14. So we can use this relationship to work out the OH minus concentration if we know the H3O plus concentration. So Kw divided by H3O plus would give us OH minus, and we can work out the hydronium ion concentration by doing Kw divided by the concentration of OH minus. So for example, if we have 0.2 mole of HNO3 gas bubbled through a solution of 1 decimeter cubed, we need to calculate the concentration. Again, we need to start off with an equation. So we have HNO3 plus water. It undergoes ionization to form 1 H3O plus ion and 1 nitrate ion. So the concentration of HNO3 will be equal to the number of moles divided by the volume. In this case, the volume was 1, so they made our life pretty easy. The concentration would be 0.2 molar. From the equation, we know that the H3O plus concentration is the same as the HNO3 concentration because it's a 1-to-1 ratio in the equation. Now, to determine the OH minus ions, we need to use Kw. Kw, the ionic product of water, is equal to the concentration of H3O plus multiplied by the concentration of OH minus. Rearranging that formula, we can work out the OH minus by doing Kw divided by H3O plus. Kw is always 10 to the minus 14 at 25 degrees, so we sub in that. Our H3O plus we knew because we worked that out from the last question, and then we can work out our hydrogen ions. Now this is a very acidic solution, so we would be expecting just a very small amount of hydroxide ions, and if we use the table on the right hand side, we could see would be right up the top of that one. Okay, another example. Calculate the H plus and OH minus concentration of a solution of 65 centimeters cubed of potassium hydroxide. Now, potassium hydroxide is a base. Bases dissociate in water. So we have our KOH, which will form potassium ions and hydroxide ions, and that's known as dissociation. For every 1 potassium hydroxide, we form 1 hydroxide ion. So we're going to use the relationship between those two to work out the concentration of OH minus. The IB might use the words dissociation and ionization interchangeably, so make sure you are aware of that. They told us the concentration of KOH in the question, so now we use the relationship between OH minus and KOH to determine the OH minus concentration. It's a 1-to-1 relationship, so that means the OH minus is 0.105 molar. To work out H3O plus, we need to use the Kw value, so we've got Kw equals concentration of H3O plus multiplied by the concentration of OH minus. Rearrange that to find H3O plus would give us Kw divided by OH minus. And then think about what this answer is going to be. We've got a basic solution. We're finding the amount of acid. It's going to be a pretty small number. So you've got to make sure you type this into your calculator correctly. And we work out the hydronium ion concentration to be 9.52 times 10 to the minus 14 molar. Now, to calculate the pH of this solution, the pH can only be calculated from the negative log of the hydronium ions, the negative log of the H3O plus. So the negative log of 9.52 times 10 to the minus 14 will be a very large number. This is a basic solution or an alkaline solution, so the pH is 13. And we expected that because we were dealing with a base. Okay, another couple of examples. Calculate the pH of a solution of 1 times 10 to the minus 4 molar sulfuric acid. Now, sulfuric acid is a little bit different. It's a diprotic acid, which means it can donate 2 protons. That means that when it ionizes in water, it will form 2 hydronium ions. So the concentration of H3O plus is going to be double the concentration of H2SO4. It's like a 2-to-1 relationship. So when we get sulfuric acid, which is a strong diprotic acid, we must make sure we write an equation, and that allows us to determine the concentration of the H3O plus. It will be double the concentration of H2SO4. So the concentration of H3O plus will be 2 times the concentration of sulfuric acid, H2SO4. In this case, it's 2 times 1 times 10 to the minus 4, which will give us 2 times 10 to the minus 4. Now to work out the pH is the negative log of the hydronium ions. So we'll simply take the pH to be equal to negative log of 2 times 10 to the minus 4. And that gives us a pH value of 3.70. And again, that is an acidic solution. To 1 sig fig, this would be an answer of 4. Okay, the final type of acid-base question that you might come up against is where we have a dilution. So if they talk about diluting a sample, then we need to use the C1V1 equals C2V2. So calculate the pH when 10 mils of 0.25 molar HCl is diluted to 50 mils of solution. So what we need to do here is calculate C2, which will be the hydrogen ion concentration. So rearranging the equation, C2 will be equal to C1V1 over V2. C1 will equal our concentration, 0.25. V1 will be 0.010, making that into decimeters, divided by our final volume, which was 50, which was 0.05. So the H3O plus concentration after we do this dilution will be equal to 0.05 molar. Now we've got the H3O plus concentration, we can now work out the pH by doing the negative log of H3O plus. That gives us a value of, can't do logs in my head, so I need the calculator. That will give me the value of 1.3. Okay, volume 3, some top tips. Write an equation to start any pH question. pH equals the negative log of H plus only, and think about your response. If it's an acid, it needs to be acidic. If it's a base, it needs to be basic. Thanks for watching, guys. Don't forget, drop a like on the video, subscribe for more, and I'll see you next time.